Welcome. Let's continue the tutorial on means friction, taking into consideration the cone. Here we are trying to find out how we can develop a cone from a sector. We did that in the episode that end where we derived the formula. Let's pick a question to see how we can text that formula. So the diagram below shows a major sector of a circle of a center O and a radius of 15 centimeters. So if the sector is folded to form a cone, we have to find the radius of the cone as the first, then total surface area of the cone. We can see this diagram here is a replica of this. So this is the major sector. We can fold this major sector to form a cone. You can see a cone is a 3-dimension. So this is a hollow cone with no circular part. So if we take this, we know this is the slant height, right? The slant height, which was originally the radius. So we developed the formula, but let's take it again by saying that if I want to find the base radius of the cone, then I know that the length of the major arc, okay, the length of the major arc is going to be the same as the circumference. If we check, the length is this arc, the lines. So if you fold it, what happened to it that this line become the circumference that will have covered the circle. So it means the circumference of the cone is the same as the length of the arc. So that will be equals to circumference of the base of the cone. So we can say that the length of the arc is given by theta out of 360 times, we say length, right? So 2 pi r. But the r is the bigger r, so we use the r this, equals to the circumference of a circle is 2 pi r. And the smaller r is what we use because that's the r of the base. When I mean the r, the radius of the base of the cone. So this is 2 times before the equal sign. I can divide by 2 pi. Then meaning that your radius will be equals to theta over 360 times only the r. So this is the formula we quoted. So we can quote this formula directly without writing the relation between them. Just this is the radius of the cone that we are looking for. So here, where our r is given to us as 15 centimeter, that's the bigger r of the sector, then our theta in this case is not going to be this. This sector is removed. It is the bigger sector which has the reflex angle as 360 minus theta, and our theta now is what? 60 degrees. So that will give us 300 degrees, meaning the theta will be 300, the r will be 15. We can find this easily. So the radius become r equals to 360 times 15. Let's just add a centimeter. You know these zeros will cancel. Then 6 will go here, 5 will go here, 6. So you'll be left with 5 out of 6, right? Times 15 centimeter. I believe 3 can do the work. 3 go here, 2, 3 go here, 5. So 2.5 times 5. Let's see. And that will give us 12.5 centimeter as the radius of the cone. Then the next thing to find is the total surface area. So finding the total surface area, we know the total surface area of a cone that has no base is called the total surface area of a hollow cone, which is the same as the curved surface area. That will be pi r what? Yeah, pi r L. And what does the L stand for? The slant height, which you mentioned that when you form your cone, the radius here become the slant height. So we are going to replace the slant height with the capital radius of the sector, meaning 22 out of 7 times R, which is 12.5 times 15. When you put that together, we are going to have 589.29 centimeter total surface area, centimeter. So you have a centimeter square. So that is what we can go through in order to find the total surface area. If you want to find it in a different way, we can also see that the whole area, the area of this, is going to be what is used in making the cone. So the area of the sector will be the same as the curved surface area of the cone, or better still, the total surface area. Everything here will be made into the cone. So we can also say that the total surface area is the same as the area of the sector, and area of the sector will be theta over 360 times pi r square, right? So what is the theta? We had it to be 300. So 300 out of 360 times pi, 22 out of 7. This is going to be 15 times what? 15. Let's do that calculation and see. And when you do that, you will still get your 589.29 centimeter square. So you can either use the curved surface area formula, which is the total surface area of that hollow cone, or you can also use the fact that the area of the whole sector becomes the total surface area of the cone. I believe in these two scenarios, you can be able to find the radius of a cone, find the total surface area, and even go ahead and find the volume of the cone. All right. Thanks for watching. Like, share, and comment. Bye-bye.